That's how 16 EVE MB56 look like. 16 times 2.2 kilowatt hours. Wow. Guys, welcome back to the Off-Grid Garage here in sunny and super hot Australia. We've got 34 degrees Celsius today. Beginning of spring, I can only imagine how summer will be. Okay, these are all the empty boxes here of the MB56 cells. And we have only almost 0 amps outside, 100% in this battery, 99% in this battery. And when I say battery, I mean batteries, battery banks. One is charging, the other one is discharging at the moment, so they are balancing. Alright, first of all, I want to label all these batteries and also scan the QR codes. So I got them in my spreadsheet. It looked strange from the beginning because these are only 14 cells, not 16. There are 2 missing. I'm pretty sure I picked up 8 boxes from the gate. Found them. This box was hiding under an empty box. These were the 2 cells I already showed you in the last video. 15, 16 and number 16. Alright, now we are complete. Wow, this scanner is so quick now. You just need to hold it over the QR code, press the scan button and it scans it in less than a second. Unbelievable. Okay, I've got all 16 cells scanned. Beautiful. And I have prepared the Yixiang tower already. So these bottom 2 we have built. This was the version 1 of the do-it-yourself box. Pretty good box, but the circuit breaker was crap. And I have refined it now. And this is the version 2 you can buy. Has a better circuit breaker, also comes with a fuse. And ventilation holes with a mesh similar to this one. So insects don't get in. And of course this all comes with the version 19 of the JK-Inverter BMS. Now this is still the version 15 of the Inverter BMS. Both of these boxes here have already EVE LF280K cells in them. So, and on top of these 2 boxes I have now stacked the MB56 do-it-yourself kit. Yeah, this massive box here sits on top of these ones, and we will put these cells now into this box and see how everything works. If there are any issues, for example, if this whole tower gets far too heavy for this wheelbase. Yeah, but these wheels here, they've got 500 kilos each, so they should be fine. And the welding of this wheelbase here is super strong, so it should be no problem at all holding these 4 batteries basically, or 3 batteries. It should be no problem to hold this weight, and we should also be able to wheel it around. And let's see if we can fit another 1 box on top of that. Because once these batteries are in place where they need to go, you are dialing down these elephant feet, I call them. These are big rubber feet and they go all the way to the floor, and then they take off the whole pressure of this wheel, which has a bit of an offset here. Yeah, it sits a bit to the side and therefore it puts a lot of stress on these wheels. But once you put them on the elephant feet, there's no problem anymore. There's a straight line holding this whole weight on these rubber feet then. And you can also make sure the batteries are 100% leveled if your floor is a bit uneven. Okay, let's take everything out here and start putting these cells in. Jeez. And this is the old front plate without a fuse. And Yixiang has already sent me the new part for the MB56 box. See, this one has the carrier for the fuse and also the 2 pins for the fire extinguisher. So we are going to replace this one with this one. But this is in a second step because we have to start here at the bottom, take out all these front panels, these compression plates, and start filling up batteries in this bottom compartment first. So what I'm going to do is now I wipe off this floor here. Just want to make sure there's no hump or any dirt inside, which could create a pressure point on one of the cells. So really making sure this is all nice and clean before we start. And we have this 100, 200, 300 amp BMS already pre-configured here. All these bolts are torqued and marked, very nice. And obviously this connector here goes to our most negative cell. and this already gets you started. So first cell has the negative here, positive here, and then you go alternating all the way back. And from there we have to use this link, which connects the bottom row to the top row. But first of all, let's take this one out and clean this here as well a bit. Alright, cell number 1 is going in. I'm just making sure this one is clean as well, because it was sitting on the concrete floor. Don't want to have any small rocks or something sitting underneath. Of course, wrong way. We just talked about it. Negative is over here. Now we've got 16 or so of these huge sticky foam EVA tapes. So obviously these go in between the next cell. Okay, cell number 2. Cleaning this up. There we go. And we've got 4 of these really thick sticky foam here, the EVA tapes. I think they are for the, either back or front. I'll probably leave them for the front if we need them at all. And I'll put if this fits in first. Yes, it does. So this needs to go in between. Nice. Okay, and I'm not sure now if these ones go to the front or back. Okay, let me push these ones in. Yeah, they are flush now with the frame. So if I put these ones here at the front like this, yeah, this is basically our space of compression then what we have once we tighten the compression plate again. So I think I'll leave them here at the front. Put another another epoxy sheet. No, there's no. Yeah, there is. Yes, yes, yes. So like this, yeah, and then compression plate, bang, done. Negative, positive. Oh, I made a mistake. Look at this, positive, positive. Oh, I have to take them all out again and turn them around. Such a noob mistake. Oh, wow. So we now have here from the back epoxy sheet, EVA tape, EVA tape, EVA tape in between all the cells. And then we've got here the thick EVA tape and the epoxy sheet for the compression plate to this side. So negative, positive, negative, positive. I'm checking 3 times now. Because it will be very hard to access this bottom compartment here once this other cage is in and the cells on the top are mounted as well. Yeah, there's no way to access these cells and terminals anymore. So when we install the bus bars now, we have to triple check all the torque settings, everything, and mark this 3 times to really ensure everything is top notch. Yeah. So is EVA tape good enough in between the cells, or do we want epoxy sheets instead, or both EVA and epoxy sheets? Let me know down in the comments below. And I think Yixiang is more than happy to take in any community feedback and make these changes. Okay, next step, compression plate with the BMS. So now we have to do a quick calculation here because of the compression. So I just looked up the specification sheet again for the MB56 cells from EVE, and they suggest a compression of 300 kilogram force as well. One screw, one M6 screw, can produce 300 kilogram of force with 3 Newton meters. Yeah, and because we have 4 screws here, we need to divide 3 Newton meters by 4 screws, which makes 0.75 Newton meters per screw. Yeah, and then we have 300 kilos of force on these cells. That's all we need. The documentation state also plus minus 20 kilograms. And of course, having these foam in between here makes this all obsolete, because the foam will compress at the beginning, and then when it gets older, it probably stops compressing in between. So with the EVA tape in between the cells, it makes it almost impossible to calculate the correct compression for these cells. So I would say if we do 1 Newton meters for the screws here, it should be fine. I tell you what, this thick EVA tape here at the front compresses a lot. Ah, here we go. There's 1 Newton meter. There's 1. There we go. 1. Okay, 1. 1. I tell you what, I probably screw them in all the way because we are almost in anyway. Yeah, let's do that, come on. Yeah, and here you can see the compression plate is now against the frame on both sides. The screws are fully in. And you can also see how the compression plate compresses a lot more here than here in the middle, yeah. There's a lot more space. You can see how it bends. Yeah, which is not great. So screwing the compression plate all the way in is wrong. You're putting more pressure here on the corners of the cell and there's pretty much nothing in the middle. And this is not great. So I'm loosening these screws again and put 1 Newton meter on them and that's it. Even there's a bit of space here, this should give us a more even compression on the cells. Yeah, so with a torque of 1 Newton meter per screw, we have about 2 millimeters of gap, 1.5 millimeters of gap here. And this gives us a far more even compression now on the cell here. All right, we leave it as it is, 1 Newton meter it is. Flexible bus bars coming with M3 threaded inserts here for the balance cables and temperature sensors. Very nice. Stainless steel flange nuts. And here the PCB carrier for the balance cable PCBs has actually a marking on it B0 to B8. So this is the one for the bottom. The other one has the writing on it B9 to B16. So this is obviously the top one then. Okay, we are sliding this one in. There goes some sticky tape underneath. See, and all the balance cables and also the temperature sensors, they have small M3 ring lugs. They go directly here on the bus bar. So, and because we have already mounted the bus bars now, we have created a 24-volt battery. And we probably want to start isolating the terminals now. We are not working on, so we can use one of these epoxy sheets here, which is very nice. And we can start installing the balance cables from here and then pull the whole sheet back while we keep working, and then put another sheet on this area here so we don't have any exposed terminals. It says here B7 on the PCB, and this cable goes obviously to battery 7 positive. So with this last link from the bottom battery to the top battery, it looks like they have cut out the back wall here to allow space for the bus bar. If I put this straight, and it's not even straight yet, it is touching the side of the panel here a bit. So it actually needs to go this way, and then it's not straight anymore to the terminal, which is not a big deal. But I wonder how it looks like here at the top then. So this cutout in the back wall is not in the right position for this flexible bus bar. It needs to be further to the middle. Okay, we have to see how this works. They have isolated the terminal at this end. So now when we put the cage in for the top row battery, it doesn't interfere with these terminals which are already connected. Yeah, but this needs a bit of adjustment. I'm thinking of if I put another layer of heat shrink here over this bus bar. Okay, double heat shrink layer protection. So the specifications of the MB56 cells say we have a maximum torque at the terminals of 6 Newton meters. So I probably go with my standard 4 Newton meters for the terminals as always. There's 4. There's 4. Black marker. 4. 4. Black marker. Okay, now I start at the beginning again and torque everything again and mark it this time with a red pen. So I've got twice, 4 Newton meters, Cell number 1, nice. Red, red. Alright, I think so far this bottom layer battery 24 volt, and I've double checked the balance cables as well. You can see the black and red dot next to each of the screws. Terminals, temperature sensors, everything is double checked now. And now it's time to put on the epoxy layer to cover all these terminals and bus bars. And then we move on and put the cage back in for the next layer of batteries. But this will be the last time we actually see all this stuff. I'm not taking this battery apart anymore. So everything is double checked, good to go. So here's the big moment. Say goodbye to cell number 1, to cell number 8. We will never see them again, hopefully. Hopefully everything is all right and the battery performs well. These holes are all lining up perfectly. I'm a really big fan of these huge epoxy sheets covering the cells and terminals. And I think we will continue tomorrow morning because it is already spat o'clock. And by the way, thank you very much for all your donations. So I will enjoy the sunset and an ice cold spat. All right, see you again tomorrow morning or maybe later tonight. Nah, see you tomorrow morning. Have a good night's sleep. Beautiful. So there is 10-12 millimeter space between this epoxy sheet and the next floor where the next level of battery sits on. So it gives the whole situation a bit of ventilation as well. Guys, welcome back to the Off-Grid Garage here. It is now the next day. Who cares, right? For you it was just a second. A short pfft. Okay, I've now mounted the second floor, the top floor, and we can place the batteries once we put the epoxy sheets all the way around. This is the positive from the bottom battery, so we need to start with the negative of the cell in this position. And cell number 16 going in. That's it. We did it. Almost, right? So negative, positive, negative, positive, negative, positive, negative, positive. I did it right this time. And we do the 1 Newton meter thing again. So the 2 standoffs for the fuse. Just gonna tighten them a little bit. And then we have this bus bar here. Obviously this side goes to the battery because it has an M3 insert here for the last balance cable for cell 16 and also for the positive for the BMS. And then we've got the other bus bar going to the breaker because a fuse and breaker are in series. Does it this way or this way? I think this way. Yes, and we have to mount this one first. So we are basically taking out this flexible bus bar, which connected the breaker directly to the positive of the battery, and replace it with this one here, which connects the breaker now to the fuse. Okay, I have to disassemble the whole circuit breaker for that. You won't have to do this because this new bus bar is already mounted when you buy the MB56 kit. So you won't have this bus bar at all. Alright, that's the whole modification. We've got the new bus bar in place. I'm just thinking of how we do this now because we need to plug in several things at the same time now. Near main positive to the terminals, all the communication cables. This one needs to go to the top actually. And I'm also not sure where to mount these trigger sensors here for the fire extinguishers. I've got 2 of them. Should be one in between the batteries somewhere. But they are clearly not made for preventing a battery fire. Yeah? They will probably put out a cable fire, but not if the batteries are burning. Which they actually can't, because this is lithium iron phosphate. They don't burn, at least not very easily. So these two cables go up to the balance PCBs. And these are the communication cables, and one is for the display. I wonder if we can plug them all in after the front panel is mounted. So we just need to tighten this screw for the negative terminal and leave all the other ones as they are. Yeah, let's give this a try. Okay, so let's mount the bus bar first. It's a bit stupid because the box doesn't sit on the floor. So I have to hold the... Let's see how this works. There's actually enough space to connect the cables now, and we could also have tightened this screw right now. So you can actually mount the front panel first and then tighten all the internal connections here. That's pretty cool. Alright, so the only problem I see now is the balance cable for the lower battery bank, because it is a bit, yeah, it is a bit further in here. I'll try. Yeah, there's probably no way to plug this one in. Nah, I can't see. Alright, good. And honestly, we could have done this before we mounted the front panel, because this has no effect on any other installation process here. BMS is already mounted, so is the PCB for the bottom battery bank, and we could have connected these two already. No, this step will be in the manual. Okay, it is probably advisable to plug all these cables in when the front plate is still off, because depending on your arm size, you may not be able to get in all the way to the bottom and fish out these cables here. So this is the last one. That's the switch. Goes in this way. Cool, all the cables connected except of the positive for the BMS, and this one and all the bus bars, of course. But all these communication cables are now plugged in. Everything is good. So I think we've got a bit of an issue here with the PCB holder, yeah? So I put the EVA tape underneath and set it on top of the batteries, and there was a huge gap between the PCB holder and the compression plate. The compression plate cannot come any higher. So when I tighten these screws now, I think the metal here of this holder is either already touching the cell or very, very close to it. Yeah, it is definitely better here in the back, because this back wall is a bit higher than the cell. But here the compression plate is so much lower than the cells. Yeah, when I tighten them, I probably put some spacers or washers underneath and use some longer screws, so the PCB holder is a bit of a distance to the cell. That is a bit too close for my taste. So this bracket angle holder situation here could be just a bit longer, so the actual PCB holder is a bit higher above the cells. That is too tight. And the holes are not lining up here either, because this piece here with the holes in it could be a bit longer, and therefore the long holes could be a bit wider. And this is because we haven't screwed in the compression plate all the way. This is probably how they tested it. But when you put the cells in, this is all the space you have. Yeah. So this situation needs to be a bit wider. Yeah, at the moment it doesn't line up. Alright, so when I tighten these screws here at the back, look at the PCB holder. It's like a spring mechanism, so it is too high here. No, the back wall actually needs to be higher, a tiny bit higher, because I'm putting pressure on the cells now already. It is not by much. But if I put a washer underneath here at the back, the situation is much, much, much better. One washer, another one there, and this one back on top. Look at this, no more jumpy anymore. Yeah, and here at the front, so I cut out these two holes to make the hole really long. Let's see if 2 washers are enough already. No, I think we need 3 actually. And this is like 3 millimeters. Yes, that's better. Because this holder doesn't need to push on the cells, yeah? It's not necessary to do that. Okay, 3 washers. Yes, and now we can tighten the screws. It's just too short. I have to replace the screws with the longer ones here for this modification. Yes, now I'm happy. Yeah, see, now there is a bit of gap between this metal holder and the cells. Probably 1 millimeter or so. And that's perfect. And we don't have this tight corner situation anymore between the metal holder and the cell. Okay, this PCB holder situation here needs some slight modifications from Yixiang. So in one of the last steps we have to connect the balance cables to this side of the battery. And in the very last step, connecting the positive of the BMS as well as the last balance cables B16. Yeah, very small spark when you connect the BMS. All right. I don't like this cabling shit here. Yeah, and then we have to figure out what to do with this trigger for the fire extinguisher. At this point I'm not sure. I'll leave it just sitting here above the batteries, measuring the room temperature or so. I don't have a manual for this battery yet, so I don't know where they belong. So I've torqued all the screws, they're all tight. And in the very last step, we put the cover here on top as well. Good. Alrighty. Okay, tighten these ones. Beautiful, nice and covered. And that concludes the build of the first MB56 do-it-yourself kit, including the MB56 cells, of course. So this is now a 35 kilowatt hour battery. That is crazy. Wow. Okay, and first time we turn it on. Oh, nice one. 628 ampere hours. Wow. So they have already pre-configured the BMS to match this battery. That's interesting. Okay, 440. Let me switch this one to, yeah. There's actually a new firmware available for this screen here as well, which has an alarm function. I can show you here on this prototype. See, there's an alarm tab as well. So you can see any alarm in any of these batteries connected. Now I'll do a separate video about all the screens you can get for the JK BMSs, what they are for, what they can do, which BMS they fit. Yeah, because we've got an alarm here at the moment, but I cannot see what kind of alarm it is. So I need to connect with the app, obviously, to see what's going on. But yeah, it is alive. MB56 battery, 628 ampere hours. And we know from the testing, it has actually over 680 ampere hours. These are all the cell voltages. So cell number 1 and 2, they could be off. They are already off. See, number 1 is too low and number 2 is too high in comparison to all the other ones. So there will be a bit of balancing happening to bring these two back in line with all the other ones, because they have all the same voltage. Look at this, 1-2 millivolt difference across all these green cells, and these ones are outliers now because we have tested them and they are not quite at the same capacity anymore as they were before. And yeah, we have to fully charge this battery now and do a top balancing and then a capacity test. But we will certainly do the capacity test in a future video because I am not at home. Yeah, well, when you watch this video here, I'm not there. I'll be in Melbourne with my son. So, but when we come home on the weekend, I'll fully charge this battery here, or it might be already fully charged by then. And then we can do a full capacity test and see how many hundreds of kilowatt hours we get out of this battery. That will be crazy. All right, then let's have a quick look at the BMS. That's this one here with a long number. Just want to see what version they deliver now. That's the 1909. There's a 1910, a 1911 and a 1913 now for quite some time. I haven't bothered making a video about the 1913 yet because there's not much improved with this firmware. So I'm not sure if you want me to do a video about this new firmware and publish it on my OneDrive. I'm really trying to push Jikong in China to publish their firmware, their apps and their PC software on their website themselves. And when I suggested this to them, they thought it's a great idea, but they haven't done it yet. So there's no official release of firmware, software, PC app, nothing. And I don't really want to be the guy to publish their software. Alright, so this is a bit of an older version still, but that's fine. Okay, my friends, in a final step, we can actually put on the big steel plate at the top, the lid. I'll just put 2 screws in so it doesn't fall off. And this concludes the build of the Yixiang MB56 do-it-yourself kit with the Yixiang delivered EVE MB56 cells. That's the whole box. 36 kilowatt hours now. So guys, yeah, now is the question. What would you rather build? 2 of these ones here or 1 of these one? The cells are pretty cheap here. Around 25-30% cheaper than the MB31 you can buy. You need only 1 BMS, of course. The box is a bit more expensive than these ones. But you're still saving a lot of money, yeah? And this one also has its own wheelbase now, which is a bit longer. You can see the MB56 box is a bit longer than the normal boxes. I'm not even sure why they're doing it, because there's so much space in the front. They could build the same box with the same length and it would perfectly fit on top of the other ones. I should have put this one here at the bottom, but I didn't want to take out the crane and fiddle around with all the boxes. We do this later at some stage and make a proper crane video, right? Alright my friends, I think so far this video from today. Let me know what you think about the build process of the MB56 box. We've seen 2 problems. One is the channel at the back where the bus bar runs in from the bottom layer batteries to the top one. This is a bit offset to the actual terminals. So they have to move this channel in the back wall a bit to the right. And then of course the PCB holder needs a bit of attention here. It needs redesigning, a bit longer, a bit wider. So it actually fits on the compression plate nicely and the metal of it doesn't push on top of the batteries. I'm just editing this video and I have forgotten to tell you about something else. Yes, here it is. I think there's one more thing we need to complain about. And this is the bus bar which I have replaced from between fuse and circuit breaker. Yeah, this was the original one, mounted like this. This was the side connected to the positive of the battery and this was in the circuit breaker. And this is exactly my complaint again. I think we have flagged this before with Yixiang and they modified the bus bars so they are not cut like this one here, yeah? So what they have done here is they have reduced the physical diameter of the bus bar. They just cut away a bit left and right to make it fit into the circuit breaker. But this is obviously not okay because we are reducing the diameter of the conductor. And this is not a 200 amp bus bar anymore, it's maybe only a 150 amp bus bar now. So they have to come up with a different idea. I think in the version 2 of the do-it-yourself kit they have somehow folded the bus bar here at the end to make it fit into the circuit breaker. Need to put this on the list as well. This needs a better solution than just cut away the bus bar. That is not good. And I'm still waiting for the manual for the MB56 kit. So that's why I was a bit confused how to connect everything together. But it makes totally sense to connect all the cables first before you mount the front panel to the box. So much easier. Yeah, and as shown in the video here, the box comes now with a 300 amp and 50 kilo amp breaking capacity fuse. In line with the 300 amp circuit breaker we have, this all is in the positive path of your battery to the terminal. Negative path goes, as always, to the BMS. Yeah, it's definitely something different to build an MB56 box instead of an LF 280K or an MB31 box or something standard, where all these cells are in one level. This is a bit of a different approach here, but I think it works out very, very well. So all the design makes sense. And we also want to have a look here at the wheels, right? If they are a bit on a lean already, no, I would say they are perfectly straight. But I would only use them now to wheel the battery in the place where it's installed, and then you turn down these elephant feet here, so the whole weight sits on these rubber feet and not on the wheel itself anymore. Okay, let's do a bit of a test drive. And this is about half a ton of weight now. Is it top heavy? No, it's not. When the wheels are not pointing in the right direction, it's almost impossible to push it that way. But the concrete floor is certainly not the smoothest here. And I've got some screws on the floor, which doesn't help either. Alrighty, so far I have only... come on. Yeah, now it wheels. As I said, the MB56 box will get its own wheelbase, which is a bit wider than the actual MB56 box. And then you can stack up to 2 of these boxes on top of each other. But they have actually tested the whole wheelbase with 900 kilos of load, and it was no issue on a smooth floor to move it around. The wheels didn't bend, nothing. So the wheelbase is actually tested with 900 kilos, real kilos. And 2 of these boxes are only around 500 kilos. So you could potentially put actually a third one on top to upgrade your overall capacity to 105 kilowatt hours. And this is all coming out of 3 batteries only. That is insane, right? All right, guys. As always, leave all your comments down below. What do you think about the MB56 box with the MB56 cells now? Would you rather build one of these or 2 of these? Of course it is heavy, but how often do you carry your battery around? As always, guys, thank you so much for watching. Thanks for all your amazing support, for everyone who is donating to the channel, buying me a sped in these sunny and hot conditions here in Australia. Thank you very much. Thank you for over 115,000 subscribers. Welcome to everyone new to the channel, and welcome to all the old ones. If you like this sort of content, please subscribe to the channel, leave a like, share these videos, and if you have already, thank you very much. Until the next video, guys, when I'm back out of Melbourne, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye.